Hello everyone, welcome to you all on IMS Gate Academy. So guys, first of all just confirm audio and video so that we can start the session. Now we are live and we are going to discuss the complete paper analysis, computer science afternoon session, and today is 1st Feb exam forenoon session we already completed. So more than 3-hour session already available at our YouTube channel. So we already collected some memory based questions from our student side. Now we are going to start here all the detailed solution of all memory based question. Those question has been asked in today's afternoon session. Okay guys. So first of all you can also confirm audio and video, and you can also write if you have attempted that gate paper today, then what was your experience, because whatever feedback we have received till now, accordingly students are saying that the question paper for computer science, even the forenoon, was also easy to moderate, and this afternoon session also easy to moderate only, not at all tough. It is easy side. Majority students are saying the question paper is easy only. So now I would like to invite our computer science expert mentor. So we have Ravi sir with us. So Ravi sir, how was the question? How was the paper?
Sir, paper was those who studied well, definitely they could have marked a good number of questions.
Many students are saying that questions are easy to moderate.
Yes, sir. So is it easy to moderate? But this time, what surprise thing happened, sir? Generally some questions past 10 years or 15 years, there was no questions on that particular area.
Okay.
But they framed the question,
Oh.
especially from COA. Booth algorithm will be there
Okay.
for multiplication, sign integer multiplication.
Correct.
Past 15 years, I never seen a
Any
question from.
both,
But ask this time, one more question framed it.
So those who only solve the PYQs, maybe they got some difficulty.
Correct. But those who covered the most of the syllabus might have solved many questions. So it is overall paper easy to moderate, and this time sir more MSQ questions were there,
Okay.
especially from COA and operating system DBMS. This time good number of questions from compiler design.
So do you have some questions to solve now?
Yes sir.
Yes. Please start it. Many students are waiting because I need to start one more instrumentation also.
Yes sir.
So I will
Yes,
start
I'll
that,
discuss.
okay?
Thank you sir. Thank you. So hello students, you might have solved some questions. We'll verify whether this all correct or not. So one question I would like, first question I will discuss on COA, especially this question framed from Booth algorithm. Okay. So in a Booth algorithm they framed. They said P is a multiplier, Q is a multiplicand. Some P value is given not required, some 1 0 1 0 1 1 0, like this number is given like this something. So this multiplier, multiplicand, Q is a multiplier. They said multiplier. So multiplier, okay. So this number is 1 0. So actually this gives same answer. Maybe one bit might have changed it, but same only 1 0 1 0 0 1 0 1 0 1 0 1 0 1 2 3 4 5 6 like this. Yes, this is the multiplier given like this. Maybe some zeros are here and changing, but like this pattern only given. Okay. So P and Q multiply, they ask number of arithmetic operations required to perform this multiplication. So when you apply Booth recording pattern, so pattern properly if you apply, in which you can understand how many shift operations required, how many additions required, how many subtractions required. So this pattern you should apply clearly. So make it try to find out the number of partial block, number of full blocks. So now this is a full block. Is it not full block, full block, full block, full block? This is what partial block. So number of full blocks, how many? 1 2 3 4 5 6. As you know, for each full block, one addition, one subtraction required. Therefore simply they said number of arithmetic operation mentioned. So one addition, one subtraction. Can I say now 1 2 3 4 5 6. So 6 into 2, 12 operations required. So now 6 additions is 6 subtraction now. This partial block required only subtraction required. So that nothing but one operation. So total number of operations required how many? 13. It is one more question. So most of you might have marked this answer is 13. Do respond everyone. This is one more question. Now from COA only, COA, another question number 2 from COA. So this is from cache memory, especially from cache memory, direct address mapping based. Okay. So now actually generally past all question papers, if you see in this area, generally they used to ask a number of bits for a tag field or word offset or set offset or block offset or tag memory, tag control memory, like these questions. But this time reverse he asked like them. He has given tag bits, number of tag bits. So tag bits is given 4 bits given now, and also cache index. So cache index bits given. So cache index bits given 12 bits. 12 bits is given now. Cache block size is given. Cache block size. Cache memory block size 1 byte only this side. 1 byte this side now. Cache block size 1 byte only. Now interestingly, what is the question he asked? So what is the size of main memory as well as cache memory, cache memory. So if it is byte addressable system only, byte addressable memory only. Memory is what? Byte addressable. So options are given. 64 KB and 4 KB. Option B given 64 KB and 8 KB. Option C is given 128 KB and 4 KB. Option D has given 128 KB and 8 KB is given now. Like this options given. It is basically a question is MSQ question. It is MSQ question, he asked it. Yes. So very good evening. Yeah. Now see. So what is given now? Physical address. To answer this memory size, physical address I should know. But they said tag plus here is block offset will be the now what comes, sorry. So here is what block offset will be there, followed by what word offset will be. Tag bits has given 4 bits here. So block offset will get from the cache index bits only. Cache index nothing but block offset number only, right? 12 bits given now, 12 bits. Now generally this word offset bits we know depends on the block size. What is the block size given? 1 byte. Please do understand, if block size having 1 byte, do we need any bits to address it? The moment you go to block number, see, when you go to block number, there is only 1 byte. Do we need any additional bits to select the bit, that particular byte? Does not require. This is 0 bits required. Therefore, the physical address equal to how many? 16 bits, isn't it? 16 bits. Physical address 16 bits, nothing but main memory size. So main memory size equal to 2 power of 16, unit is byte. This is nothing but 64 KB. So when 64 KB comes, now option C and D can be eliminated. Either A and B will be there now. So with this respect, we need to find out even cache memory also. So cache memory, please understand. How to get the cache memory? Cache memory nothing but number of cache blocks, isn't it? So number of cache blocks. So number of cache blocks into block size, I can do it. So number of block size, can I get it through this one? Because block offset number gives the 12 nothing but. So 2 power of 12 into what is the block size? Block size is 1 byte only. This is nothing but 2 power of 2, 4 KB. So cache memory size is 4 KB, main memory size is 64 KB. Therefore, option A is right. Sorry, this is MCQ question only, not MSQ. MCQ question only. This is MCQ question only. So I hope this is clear, everyone. Yes. Next. So third question from question number 3 something. This is 2 mark question only asked. COA from memory organization like related to memory hierarchy. Subtopic is what? Memory hierarchy. They said 2 level, this given like 2 level cache memory, 2 level cache memory and main memory also given now. So main memory. main memory given now. Okay. Now L1 cache I am writing, L1 cache, verbal statement given, but L1 cache iterate given, iterate is 90%, iterate is given, comma, its access time, let me write T1 is 1 nanosecond I mention, 1 nanosecond mention now. Level 1 access time is what? 1 nanosecond given. So level 2 cache memory, it ratio 80% given, comma. So they said miss penalty from level 2 to cache to level 1. They use a word, please understand. So generally confusion will be the student have a confusion. Should I use a level by level formula, level by level hierarchy, or parallel connection is a confusion here now. Very simply stated in the question, there is a miss penalty from level 2 to level 1 caches. So that is nothing but T2 is 10 nanosecond given now, 10 nanosecond now. So main memory miss penalty from L2. They also mentioned miss penalty from L2, that is nothing but main memory access time 100 nanosecond given. So he asked T average access time, T average access time. So you have learned from the class, right? Simplified expression for level by level connectivity, compulsory 3-level memory hierarchy, level by level connection is there. Whether level 1 it or miss compulsory required to access the level 1. If there is a miss in L1, penalty is what? Penalty is nothing but level 2 access time. If there is a miss in L1 as well as L2, penalty from what? Level 3 is required. This is a simplified expression, we can write it. No much hangama required to write it. Simply no, compulsory T1 is required. There is a miss, L1 miss, then penalty. If miss in L1, L2, penalty required, that is nothing but what? Main memory access time. 1 plus, this is what? 90% iteration, nothing but 10% miss rate into what? 10 nanoseconds plus 10% into 80% iteration, nothing but 20% miss ratio into what? 100 nanosecond. So this value will be 1 plus 1 plus, this is 2. So simply I can say 4 nanoseconds. So range is, he said express into 1 decimal point. 4.0 to what? 4.0. This exactly answer for this question. Yes, everyone. I hope this is clear. Let me take another question, 4th question. This is a 2-mark question. So this is 2-mark question. Previous one also 2-mark question only. This also 2-mark question. 4 marks we got. 4 marks. This is 1-mark question now. So till now 5 marks from COA only. 5 marks from COA only. 5 marks from COA only now. So let's take question number 4 like this. From COA only, instruction pipeline based question. This is also from 2-mark question. 2-mark question. Now see 6, 7 marks over. Till now 7 marks from COA. So they said 5-stage instruction pipeline. 5-stage instruction pipeline. Okay, 5-stage instruction pipeline. And stage delays given now. Stage delays. So stage delays like this, 150 nanoseconds, comma 250 nanoseconds, comma 100 nanoseconds, comma 200 nanoseconds, comma 250 nanoseconds. 1, 2, 3, 4, 5. And latch delay means interstage buffer delay is given 10 nanoseconds. 10 nanosecond now. Now the question was time required to execute 1000 instructions. 1000 instructions in this pipeline. So in this pipeline, in microseconds. So microseconds he asked. It. In microseconds he asked. Simply time for pipeline for executing 100 instruction k plus n minus 1 into this is what? Cycle time nothing but maximum stage delay, isn't it? Maximum stage delay plus what? Buffer overhead. This value is nothing but 250 nanoseconds plus what? 10 nanoseconds. This is nothing but 260 nanoseconds, isn't it? So now this k is what? 5 plus 1000 instruction means 999 into what? 260 nanoseconds. So this value is what? 1004 into 260 nanoseconds. 260 nanoseconds. Just a minute. 1004 into 260 nanoseconds is equal to yes 261040, right? 261040 nanoseconds, isn't it? Now when I express into microseconds, what happens now? This will come here, right? So 26.10 microseconds. So they asked us to express up to 2 decimal places, nothing but your answer. So range. So 26.102. So 26.11 may be given range like this. This is the 4th question from COA only. COA. From COA. Next. Some more questions of COA we'll see. Before that, we also got some questions from computer networks. So computer network, first question. They said UDP segment, they said segment size 74888 given now. So now Ethernet, so IP data, sorry, Ethernet frame can carry 1500 bytes, they mention 1500 bytes here. Okay, 1500 bytes. Then they ask question now. So number of, please, and also they mention IP header as IP header. So do not have option field. Do not have option field. Nothing but what? IP header size, minimum header size what? 20 bytes, isn't it? 20 bytes. Minimum header is what? 20 bytes. Option field, nothing. It is not there. Nothing but minimum is what? 20 bytes will be there. They ask question number of fragments, and last fragment size. Last fragment size including header. They ask like this. Now you understand now as a solution part. So maximum transferable unit is what? 1500 bytes, nothing but this is what? So 1500, like 1480 plus 20 bytes header, because 20 byte header means they clearly mention do not have option fee, minimum header size 20 bytes only now, isn't it? So this 1480. So with this respect, number of fragments. So fragments, anyway 1480 divisible by 8 only. So I can take it like total 7488, because this is a UDP segment, right? UDP means asterisk will come only, right? So UDP given to what? Network layer IP, UDP plus header will be there, right? That header I am not adding. So payload divided by what? 1480. This comes 5 point something, like 5.6 something like this comes. So this nothing but number of fragments. So fragments equal to how many? 6 fragments required. So last fragment size. How to get it like now? So I should get it first 5 fragment into 1480. So 5 fragment into 1480. So 5 into 1480. Okay. So 7400 minus 7488, isn't it? So 88 we got, isn't it? 88. So 88 payload plus what? 20 header, isn't it? This value is nothing but what? So 108. So 108. So one of the option now answer. What is the answer? So answer is 6 and what 108 number of fragments and last fragment size. So this is the answer for this question ma. I hope this is clear everyone. So second question from computer networks, from flow control. There was a question flow control in which a sliding window stop and wait protocol. Stop and wait protocol based question was there. It is also again 2 mark question. Given the given data is given. Packet size is 3000 bits. So bandwidth, link bandwidth 2000 bits per second is given. Propagation delay between two nodes is 100 milliseconds as given. 100 millisecond is given now. So they are asking like efficiency of. So efficiency asked. Efficiency of what? Stop and wait protocol. Efficiency asked. So efficiency of stop and wait protocol we know. So transmission delay by total time. But also they mention so negligible all the other. So what they mention processing delay, queuing delay. So ACK transmission delay all are ignored only, neglected mention now. So transmission delay by total time. So now transmission delay by total time nothing but transmission delay 2 times of propagation delay to consider, because other things are what you can say, other things are ignored only. Total time may this all are included, but that is not given, ignored only. So get the transmission delay. Transmission delay nothing but L by B only, right? So 3000 bits. So 3000 bits divided by 2000 bits per second. 2000 bits per second now. So bit cancel, 3 cancel. This is 1.5 seconds, is it not? So 1.5 seconds, correct or not? Other unit is milliseconds. So this nothing but 1500 milliseconds will come, isn't it? So 1 second equal 1000 milliseconds, right? So 1500 milliseconds we got, 1500 milliseconds we got, isn't it? To transmission delay now. So efficiency equal to 1500 milliseconds, 1500 milliseconds divided by 1500 milliseconds plus 2 times of propagation delay. Propagation delay is nothing but this is going to be 200, isn't it? So 1500 by what? 1700. In terms of percentage he asked, so into 100 I have to do. So this value will be, so 1500 divided by 1700 into 100. 88.23, there is an option actually, 88.23. So there is an option, so option need to select. MSQ question, this was MCQ question. This question was MCQ question for 2 marks. MCQ question asked. MCQ question is asked. Some more questions, some other faculty will come and discuss. So be stay to the channel. Rohit, come. Have some questions?
Hello everyone, good evening. Let's continue discussion this C programming related question here. Fine. See here, the first question is, let's take from this C programming question. Okay. Now this question is from pointer and array. Question is here. Let's take this int main. We are having this one integer declare here is integer a. Fine. Then we have one integer array, and elements are given here is 30, 50 and 10. Fine. Now here some statements are given. Okay, am I audible? Fine. So statements are given here. Integer pointer ptr is equal to n% arr of 0 plus 1. Fine. Then the next statement is a equal to star ptr. Fine. Then we have this star ptr, then post increment. Okay. Then we have this ptr equal to ptr plus 1. Fine. And the last statement is one printf statement. Here we have the printf statement, %d. We have this a plus arr of 1 plus star ptr. Fine. This was the complete given question. Now see. See here, we are given with one array. Fine. So let's take one array, and also we are given with one integer variable. So let's take this integer variable a here. Okay. See here. So this is our variable a. Let's assume the address is 1000, and this is initially having this garbage value. Fine. This is our array arr. Fine. Now here let's assume array is having 3 elements. The first is nothing but 30. Here it is a 50. It is a 10. Let's take the address here. Address is, let's assume this is a 2000, 2002 and 2004. Fine. Done. This is our array, and this we know this array name contains the first address of the first element here, the first element address. Fine. Now see here, let's take here first statement is here. First statement is here that star ptr. Okay. Star ptr is equal to okay. Int star ptr is ptr is a pointer. Okay. So let's create one pointer ptr here. This is our ptr. Now here the ptr is equal to n% arr of 0 plus 1. If you know what this arr of 0, this arr of 0 nothing but the address of the, we can say this is the value of the first, means array first index element first index here, or we can say this nothing but here n% star of arr of 0 plus 1. So what is this here, nothing but this star of ar plus 0 nothing but the 30 here. Okay, the value 30 here. So what is n% 30? N% 30 means the address of the first element. It is our 2000. Getting mad? That is our 2000 here. So basically this complete nothing but our 2000. Okay. So what is 2000 plus 1? Again address arithmetic. So again if I am adding this 2000 plus 1 means skip one element. Fine. So if you skip one element, then it will be nothing but 2002 only. So this 2002, the final value nothing but here 2002. Now this will be stored in the ptr. Means ptr is having 2002. It is pointing to this address. Understood? So first statement this is done here. This is done. Next is our a equal to star ptr. What is ptr? Ptr is having this 2002. Now what is star ptr? Value at 2002. This is not but here 50 here. 50. Okay. It means this 50 will be stored inside this a. Means a is having 50. This is having 50. Fine. This is also done. Next is our here. Next statement is our here star ptr and then plus plus. Fine. Because we know the highest priority is of bracket, so first resolve this bracket. Okay. So what is bracket? Inside the bracket we are having a star ptr. So what is ptr? Ptr having 2002 here. 2002 here. So what is star? Star 2002 is nothing but here. We can say this is nothing but here. The value at here it is our 50. What is 50 plus plus? So this value will be incremented by 1. This is nothing but 51 only. Understood? So this is also done here. The last one is PTR equal to PTR plus 1. So what is PTR equal to PTR plus 1? See here, PTR is equal to PTR plus 1. Again, assignment having L value and R value. So first resolve the R value. So again, inside the R value we have PTR plus 1. So what is PTR? PTR is 2002. 2002. Again, address arithmetic here. So what is 2002 plus 1? So skip one element from this 2002. So skip this element, you are at 2004. So it means this complete value nothing but 2004 only. Understood? So this will be related to this PTR. So now the PTR is having 2004 here. Understood? Now this link is here. Now this PTR is pointing to 2004 here. Getting my point? 2004 here. Done. So this statement is also done. Now see the printf statement. What is A? What is A here? What is A here? So A value is nothing but here it is a 50. It is a 50. What is ARR of 1? So again ARR of 1 nothing but here star ARR plus 1. So what is ARR? ARR is the address of this first element 2000. So 2000 plus 1 is nothing but here the second element. And what is star? Star, this complete value nothing but 2002. What is star 2002? Nothing but here this 51, or we can say the first element at the first index. Okay, this is having 0th index, this is the first index. So element at the first index here. So value is nothing but here, this is nothing but 51. Understood? And this value is nothing but here again star PTR means PTR is having 2004, star 2004 is value at 2004 is 10 only. So this value nothing but here 10. Understood? So final total value will be 50 plus 51 plus 10. This will be equivalent to 111. Getting my point? 87? No. 87 बता रहे हैं. I'm not getting. This answer is 111, 111. Fine. Okay. Now see next question quickly. Next question. The next question is okay. Again from the data structure. This is a BST based. It says here. Okay. Consider a BST. Okay. Consider a binary search tree with elements. Elements are given here. Elements are here. We are having this 10 minus 4. Then we have this 13. Sorry, it's 13. Then we have this 30. Okay. Then we have 20. Then we have 5. Then we have 16 and 9. Okay, as per the given data here, this is 19, last is 19 here, fine. Understood? This is the given elements for this given BST, fine. And the question is, okay, find the number of edges, okay, find the number of edges from node 19 to root. Okay, this is the question here. So first let's quickly create the BST for the given data here. So first is our 10 here, this is our 10. Then minus 4 will be here, minus 4. Then where we 13, 13 is more than 10, so it will be right subtree, here is 13. Then is 30, 30 will be the right subtree of 13, here is 30. Then we have this 20, 20 is more than 10, more than 13 and less than 30, so here it will be 20. Very good. Now again see where is 5, 5 is less than 10, so left subtree, and 5 is more than minus 4, so it will be in the right subtree of minus 4. Then where is 16, 16 is more than 10, more than 13, less than this and less than 20, so here it will be 16. 16, fine. Then we have this last is 19, so 19 will be more than 10, right subtree, left subtree and here right subtree. So 19 will be the right subtree of this 16 here, fine. So again just count the number of as. So we are having this as 1, as 2, as 3, as 4 and the as 5. Understood? So from this node 19 to the root, we are having total 5 as 1, 2, 3, 4, 5. So answer will be the number of edges. It will be equivalent to 5. Getting my point now? Fine. Let's discuss one more questions here. See, one more questions. The question is given here is again from the data structure. Okay. The question is consider an array. Consider a array with n distinct element or values. Okay, and the question is find the number of comparisons. find the number of comparisons, okay, find the number of comparisons for the element that is not largest, So we have seen this such a problem in the classroom here. Okay, we have already seen how many comparisons required to find element that is neither maximum nor minimum, that is a constant time. Okay, take the first 3 element and it will give you in 2 comparisons we can find the element which is neither minimum nor maximum here. But they have just tricked the question here. They are only asking the number of coincidences required for this element that is not largest here. Fine. Now see here, we are given with array n. Okay, so if we are having n elements in the array here, okay, we are given with n elements in the array, like here we can say here a1, a2, a3 up to an. These are the n distinct elements in the array. Fine. And if you need to find, okay, the element that is not largest means, okay, no need to scan the complete array, just take the first 2 elements, okay, take the first 2 elements and then perform the comparisons. Then what we can say here, if a1 is, okay, just see here, if a1 is greater than a2, then we can say the return I can say return a2, because a2 is not largest. Why? Because there is an element a1 which is greater than this a2, it means a2 is not largest. And else return the a1. Okay, in case if a2 is greater than a1, it means a1 is not largest here. So again it will simply take one comparisons to find the element which is not largest. Fine. And the options was given here, 2n minus 1, b was n minus 1, and c was something, and d option was some none of this, like here. Fine, none of this. So answer is simply this option C, that is only one comparison is required. Understood? Fine. Let's see here next question quickly. Next question is one operating system questions. Let's try quickly here. Operating system. It is simple questions. Okay. So there is consider a system. Okay, that is using SRTF. Okay, SRTF scheduling algorithm. Okay, SRTF. Now here the data is given here. We are having this process and their arrival times and burst time are given. Okay, here let's assume this is a arrival time, this is a burst time. These are the processes. Fine, we are having this P1 processes, arrival time is 0 and burst time is 10. Similarly, the process P2, arrival time is 1 and the burst time is 13. Process P3, arrival time is 2, okay, and the burst time is 6. Here is our P4, arrival time is 8 and the burst time is 9. Fine. And we have discussed, and the question was find the average TAT. Find average TAT. Fine. So we have already seen in the classroom such problems. Okay. How to use this SRTF. SRTF is nothing but, we know SRTF is nothing but a preemptive algorithm. Fine. Here this SRTF nothing but it is a preemptive algorithm. Preemptive scheduling algorithm. Fine. So let's quickly draw the Gantt chart for this given problem. Gantt chart. See here. See, now let's start with the 0. So at time 0, see, process P1 is in the system. So schedule the process P1. So P1 is here, see, okay, P1. Fine. Now see, now the next process coming in the system is at time 1. Okay. So just execute this process for one or we can say 1 unit of time. Now the left time for this P1 is having, this is nothing but 9. Now at time 1, process P2 enters into the system, or we can say process P2 in the ready queue here. Now in ready queue I have two processes, P1 and P2. Getting my point? But here P1 is having the shortest burst time as compared to the P2. So again P1 will be continue. P1 will be continue here. So P1 is continue. New process is coming at time 2 here. So P1 will be continue till this 2. Getting my point here? Now at time 2, okay, this P1 executes one more unit of time. So left burst time is nothing but 8 only. Understood? Now at time 2, I have 3 processes P1, P2, P3, and among these 3, the process having the shortest burst time is nothing but, we can say here, it is having the P3. So now this P3 will be scheduled here. This P3 will be scheduled. Understood? Getting my point? Now P3. So next process is coming at time 8. So this process P3 will be continued for this 6. So at time 8, okay, P3 anyhow it will complete its execution, because for the P3, so that P3 is having burst time is 6 and all the burst time 6 is completed in between this time here from 2 to 8 here, fine. So now at time 8 this P3 is having 0. Getting my point? Now at time 8, see, P4 arrives in the system. Now in the system, P3 already completed. Now in the system I have 3 processes, P1, P2 and P4. Among P1, P2 and P4, P1 is having the minimum burst time, minimum remaining burst time, fine. So now this P1 will be scheduled here, fine, and P1 requirement is 8 only. P1 requirement is 8 only, fine. Now see here, now P1 requirement is 8 only. Getting my point? Understood? Any doubt? Is this correct data now? Done? Okay, let's continue, fine. So P1 requirement is 8 only. So let's continue with the P1 here. So P1 requirement is 8. So 8 to 8 is 16. Fine. So at time 16 this P1 is having 0. Burst time is 0. So P1 complete at time 16 here. Now in this at time 16 we have the 2 processes P2 and P4. Among this P2 and P4, P4 is having the remaining burst time is lowest remaining burst time, fine. So simply schedule this P4 here. Okay. Now P4 will take 9 burst time here. So from 16 to 25. At time 25, this P4 completes as well, means the remaining burst time will be 0 here. So P4 is also done. So left out is P2. Just schedule the P2 here. And P2 requirement is 13 here. So it will complete its execution at 38. I think 38. Fine. So it is having the 0. So at time 38, P2 completes its execution. Fine. Done. Now see quickly. See here. So what is the completion time for all the process? Completion time for all the process here. So P1 complete at time 16 here. P2 completes at time 38, and P3 completes at time 8 here, and P4 completes at time 25. Fine. Very good. Now what is TAT? What is TAT? What is TAT? TAT is nothing but here. TAT is nothing but here is, okay, completion time minus arrival time. What is completion time of P1 is 16. What is arrival time is 0. So 16 minus 0 is nothing but here 16. Similarly here, what is the completion time of P2 is 38. What is arrival time? 1. So it is remaining this our 37. Fine. Similarly here, the completion time of P3 is 8 and the arrival time is only 2. So remaining time will be 8 minus 2 is 6 only. Similarly, what is for the P4? So completion time of P4 is 25 and the arrival time is 8 only. So 25 minus 8 is nothing but here it will be 17. Understood? So these are nothing but the TAT of the process. So if you find the average TAT, it will be nothing but here 16. Okay. 16 plus 37 plus 6 plus 17 divided by 2. Oh, sorry, divided by 4 here. Fine. So we will find this. This will be data here. Fine. Okay. Now let's see the next question here quickly. Next question, see here. Okay. This is from the data structure. Question is, consider a binary tree. Consider a binary tree, fine, in which every node okay, every node is having either 2 child or 0 child. Understood? Let here, let n is greater than 0, okay, be the number of nodes in T, okay, be the number of nodes in the tree, T, fine. And the question is, which of the following is number of nodes in a tree T that exactly have, okay, that have exactly 2 children, that have exactly 2 children. So we have already discussed in the classroom this problem. Fine. So if you see here, just take, okay, options are given here is n plus 1 by 2, n by 2, C option is n minus 1 by 2, and here the D option is nothing but n minus 2 by 2. Getting my point? Understood? Now see here, now see. So here, so in the classroom we have already seen. Let's take a sample example here. Let's take an example here. See this tree. See here, this tree is as per the given definitions here. Every node is having either 2 child or having the 0 child here. Fine. So for such tree, we have already calculated the total number of nodes here. The total number of nodes, it will be equivalent to. See here. First tell me how many of internal nodes we are having here. Internal nodes we are having. See, these are the internal nodes. Getting my point? Done. Now see. So because of this internal node, see here, because of this internal node, these 2 child nodes are counted. Similarly, because of this internal node, these 2 child nodes are counted. Means I can say these 2 nodes are counted here. And because of this internal nodes, these 2 leaf nodes are counted. So if you see properly, because of all this internal node, these many nodes are covered. Getting my point? So what we can say, total number of nodes, it will be equivalent to 2 times of internal nodes, n plus 1. Plus 1 why? We have discussed in the classroom. This plus 1 is for the root node. This is for the root node. Okay, because this root node is not covered by any of these internal nodes. Fine. So it means this plus 1 is for the root node. This is for the root node. Now if you generalize this formula, then simply total number of nodes in here, and it is given n here. So n is equivalent to 2 times of internal nodes plus 1. And we know the question is asking here, okay, find the number of nodes that is having the exactly 2 children. Means find all the internal nodes here. Fine. So again here, this internal nodes will be nothing but equivalent to here 2 times of internal nodes is equal to n minus 1, and here internal nodes will be n minus 1 by 2. Okay. Fine. So answer will be n minus 1 by 2. That is option C. Option C is the right answer. Done. Very good. Now let's see any questions here. Okay, yeah, one more question is based on the GCD here. The question is from the C programming. See here, the question is our main. We are having this int x equal to 126 comma y equal to 105, and then here one loop is given, do while loop here. Do if x is greater than y, then simply perform x equal to x minus y. Fine. And then otherwise else here, else y equal to y minus x, Very good. Then here after this we are having this while condition, while this loop will be continued till x is not equal to y, Fine. And finally here just printf the final x value. Understood? Fine. Let's try this quickly. See here. If you see here, so actually always start from the main functions. So in the main functions we have 2 variables, x and y. See here, we have this x and we have this y. Okay, let's keep this x and this is y here. Fine. X and y. That's the address is 1000. Here it is a 2000. And values are here 126, and here it is a 105. Fine. Done. Now start this loop here. So do first execute this here. If x is greater than y, true or false here, x is 126, y is 105. So condition is true. So if condition is true, then simply perform x minus y and update this value to x here. It means x equal to x minus y. What is x? X is 126. What is y? 105. What is this value here finally? The value is nothing but here is 1 and this is 2, 21. Now 21 will be updated to this x here. Understood? So x value is nothing but 21 here. So if it is done, so if condition is true, then execute this and just skip this else part. Then finally go and check this while condition. Is it true or false? See here, x is not equal to y. Is it true or false? It's true only because the x is 21 and y is 105, so it's true. Condition is true. Then again perform the same here. Again check if x is greater than y. Is it true or false? It's false here. Why? Because x is smaller than y here. So if it is false, then execute this else part. What is else? What is else here? What is else? Else is nothing but here y equal to y minus x. What is y? Y is 105. What is x? It is a 21. What is value here? So simple. It is nothing but here. It is nothing but here 4 and it is nothing but 8 here. So it means the y value will be final y value will be nothing but here. This is 84. 84. So after this else, just go and perform again the while loop, testing the while loop. Again see here. So while loop is x is not equal to y. Is it true or false? Again true. Why? Because x is 20 and y is 84 here. True. Then again go and perform the loop here. Again check. Condition is if x is greater than y. Is it true or false? It's false. Why? Because this x is 21 and the y is 84. Condition is false. Then perform the else part. Again the else. What is else? Else is y equal to y minus x. What is y? What is y? Y is 84 minus 21. What is the final value here? So this value will be here 3 and this is 6 here. This is 63. 63. Again check here. Condition is true. Again both are not equal. Then again perform here. Then again see if condition is false. Why? Because x is 21, so condition is false. So 21 greater than 63 is a false. False means go and perform the else part. What is else? Third time here. Y equal to y minus x. What is y? 63 minus 21. What is value? There is nothing but here is 2. Okay, it's 2 and this is 4 here. 2 and okay, 2 and 4 here, 42. Now 42. Final value of the x is here 42. Again perform one more time here while check here, check the while condition. Condition is true. Why? Because 21 is not equal to 42. True. True means again perform the while condition. If you again check here, condition is false, then go and perform the else part here. So what is else part? 4 time. 4 time is y equal to y minus x. What is y value? It is 42. 42 minus 21 is nothing but, again it's nothing but here 21 only. 21. It means this y value is 21. Y value is 21. Now check here, condition is true or false. This condition is now it's false here. Why? Because x is also 21 and y is also 21. Both are equal. Okay, because of this while condition is false. If condition is false, then loop will terminate and we'll come back to this print statement. So what is the final value of x? Okay, the final value of this x is nothing but it's 21. 21. Getting my point now? Understood? It means here means just basically this is a standard code for the GCD. Finding the GCD of x and y here. Okay, so it will take here the answer is nothing but 21 only. So the final value of x is 21. Answer is 21. Anyhow, if you don't know this GCD code, simply execute the code. This given code, just perform this while loop. Finally, we will get the x value 21. Okay, fine. So this is the okay. Let's take one more question of this programming. One more question of the programming here. C programming. Okay, the question is here. It is a main int sum equal to 0 and n. Fine. Then we have one for loop n equal to 1, n is less than 3, n plus plus. Okay. Now here inside this for loop we have this n plus plus, and then here we are updating this sum variable plus equal to, okay, we are calling this function f of n. Fine. Then here, okay, done. And after this for loop we have one printf statement, printf %d, and we have the sum. Means finally what is the sum value? Sum value. Fine. And here the functions are given here. This g function is given. This g will take one parameter n, and it will return the value. It will return the value. Okay. Return 10 plus n. 10 plus n. Fine. And this f function is having this parameter n, int of n, and it will return okay, it will return g functions 2 times of n, or we can say it's a 2n. It's a 2n. Fine. This is the complete given. This is the complete given code. Very good. And asking what is the final value of this sum, just execute the sum value. Done. So see here, quickly see. See here, again execute. Let's start this main function. See here, main is having two variable, one is sum and one is n. So quickly let's create the two variable here. It is a sum and it is n. Fine. See here, this is our variable sum, this is variable n. Now sum is initialized to 0 and variable is having, for now it's a garbage value. Now inside the for loop, this n is initialized to 1. So here this n is having this value 1. Understood? Fine. So after this initialization, the control will move back to the condition checking. So n value is 1, less than 3, its condition is true. If it is true, then execute this body here. Fine. Now see, for n is equal to 1, for n is equal to 1, execute the for loop here. Now see again, the for loop is having n plus plus. N plus plus means now this n will becomes 2, n will becomes 2 here. Getting my point? Again see, after this increment, then call this function here. So sum equal to sum plus g of f of n. What is this n? We are passing this value as a 2 because the n value is 2 here. Fine. So what is f of 2? What is f of 2? See here. This f of 2. What is f of 2? So if I pass this f of 2 here, so it will take here, see, this f of 2 is nothing but it will take this function n is equal to 2, n is equal to 2 in this function f here, and it will return the g of 2n. Means now this f of 2 will call the gn here, g of n. So what is g of n? G of 2 only. Now what this g of 2 will return here? This g of 2 will return, this will return here, okay, this will return here 10 plus n, 10 plus n. Getting my point? So what is this n value? For the gn, n is 2 only. So it will return the value, okay. So it will return the value, okay, 10 plus n, okay, 10 plus n. What is n? N is 2 only. So it will return 10 plus 2 is 12 only. Fine. So what is the value of this here? Complete value is nothing but it's 12. Okay. Now this value will return to the function. Okay. From where it was called here? F of 2. F of 2. Getting my point now? So again, this f of 2 value, this complete value is 12 here. This value is 12 here. Now again, it will call with g of 12. G of 12. So this is equivalent to sum equal to sum plus g of 12. G of 12. See here, g of 12. Again, if I pass this g of 12, then it will add just 10 plus 12. 10 plus 12. So final value of this here, this value nothing but here, 10 plus 12 nothing but here is 22. It is 22. Okay, and the sum value is nothing but 0. So 0 plus 20 nothing but here 22. So this 22 will be updated to this sum here. So sum value will change to 22. Getting my point? Now see here. Finally, okay, this statement is done here. Fine. Then again we'll go and increment the n value. So n value will change to here 3. N value change to here is 3. Getting my point? Understood? Okay. Fine. Done. So this should be n equal to n plus. This should be n less than equal to n. N less than equal to n. Is it correct code? Less than equal to n. If it let's execute for less than equal to n here. Fine. It is 3. Then again n plus plus means 3. Then execute one more time for n equal to 3. For n equal to 3. Fine. Then what will happen? Again we'll pass this n equal to 3 means it will be nothing but here. It will be nothing but here. Okay, n plus 3, n plus plus means n equal to 4 here. N value will be 4 here. Fine. Again we will be called here sum equal to sum plus g of f of n. What is n here? What is n? N is 4 only. N is 4. So again if you call here f of 4 here, so what will happen? F of 4 internally calls this g of 2n. G of 2n na? Sorry, again here this is g of 2n. Okay, so when we are calling here g of 2n, this will be 4 here. Fine, this will be 4 here. Fine. Let's take here this value here. Let's take one more time here. Okay, see. Okay, see here. This will be sum is 0 here. Fine, for now it's 0. Again n plus plus means it will be incremented to, okay, it will be incremented to 2 only. Fine, done. Then we'll call here sum equal to sum plus g of f of n, f of n. Fine. Again, first find this value here. So we'll call here f of n. So it will be nothing but equivalent to sum plus g of f of 2. F of 2. What is f of 2 here? F of 2 is nothing but see here, n is equal to 2. Now inside this f function here, it is calling with g of 2n, g of 2n. So this will be equivalent to, okay, g of 2n means this is nothing but here 4. Getting my point? So here now see this g of 4. If I pass this g of 4, so n value will be 4 here, n value will be 4, and it will return this value. Okay, it will return the value 10 plus 4 is 14 here. It is 14. Getting my point? This complete value will be 14. Now this value return to this parent function call. This f2 value is nothing but here 14. This is 14 here, 14. So this f2 value is nothing but here 14. So this complete statement is look like here sum plus g of 14, g of 14. Getting my point? Understood? Done now. G of 14, 4 and 4 plus 10 is nothing but 14 only. Fine. Now see here. Now again, if we call here, again if you call here, this is 4, 4 if you pass this g here, n is n equal to 4, 10 plus 4 is 14, fine. This is correct only. Now see, just pass this here, g of n, so n value nothing but here 14, n value nothing but here 14 here. So if you pass n value 14, then simply it will add this 10 here. Simply it will add this 10 to the n here. So this will become here 24. This will become here 24. Understood? Now what is the sum? Sum is 0 here. So 0 plus sum is 24. This value nothing but here 24. Getting my point? Understood? Fine. So this 24 related to sum here. Sum is nothing but here. Now it's 24 here. It's 24. Understood? Clear? Fine. Now I can see. Now n will be incremented to 1. So this will becomes here. This will becomes our n equal to 3. N equal to 3. Execute one more times for 3 here. N equal to 3. I can see n plus plus this will become 4. Getting my point? Then see here. Since see here. Sum equal to sum plus g of f of n. What is n? N is 4 here. So I can call this g of f of 4 here. F of 4 will nothing but here it will nothing but here n of 2 here. N of 2. And what is this f of 2 here? It will call this g of 2n. Sorry, n is 4 here. N is 4. It will call this g of 2n. 2n means 8 here. 8. Again, what this 8 will return here? It will return here 18. 10 plus n is 18 here. Fine. So f of 4 is nothing but here 18. Understood? So this f of 4 here nothing but here is 18. So this will be equivalent to sum plus g of 18. Understood? Fine. So finally this g of 18 nothing but here is 10 plus 18 nothing but here is 28. What is sum? Previous sum is nothing but is 24 plus 18. So this will be equivalent to 8 plus 4 is nothing but here is our okay, it's 2 and 4 plus 4 52. Okay, this will be nothing but here is sum is 52 here. Now next time this loop will break and then finally print the sum value will be 52 here. As per the given data, this will be 52. Okay, so answer will be 52 as per the given data. Fine. So all question discussed. Now this Ravi sir will come and he will discuss if any question is remaining. Fine. Okay. All the best. Bye bye. Take care.
Hello students, some more questions we got, let's discuss. The question is from, one is from operating system, like memory management, like paging concept. Under this paging, they frame the question from paging. The given data is a logical address space as given 2 power of 32 bytes. Logical address space given 2 power 32 bytes. And they said 2-level system, 2-level paging architecture they given now. And the page size given, page size is given 40, so 96 bytes. This is nothing but 4 KB only, 4 KB. And the B bits are used to index outer level page table. Outer level page table they given now. And also there each inner, like each entry in inner level page table. Inner level page table is given 8 bytes. 8 bytes given now. Each inner level page table is given 8 bytes given now. Just a minute. Then all the level page sizes are same. All sizes are same also. But you know, each entry in the inner page table only given. Outer page table entry value is not given. Careful this with that data. Okay. So logical address space 2 power of 32 nothing but logical address is what? Logical address is what? 32 bits, isn't it? So now a process which is running in a CPU, it generates a logical address. How much? 32 bits generated, isn't it? Okay. So 2-level paging applied. Okay. First level paging if apply, page size how much? We have to divide by page size. What is page size given? 4 KB nothing but. So let me write offset value, this 12 bits required. So page number required only 20 bits. Again we have to apply 2-level page, second level paging. But we do not know size of the page here now. Actually this will point to what? Outer page table, correct? This will point to what? Outer page table, outer page table. This offset value, please, this offset value gives the entry in what? Like if you go to this entry, X location, X is address frame number in which inner page table is present now. This offset value, let's take now P1 I am writing, this D1 I am writing, okay, D1 I am writing. So this will give the now frame number will give now like this. So now I can pad this D and this frame number F. So we'll get what? Physical address, right? Physical address will get now. So but they're asking question how many bits for this one? They're asking like B only, this said B value they give it like this. They're asking now. Outer number of bits required to indexing into what? Indexing into outer page table they're asked. But the one thing they told, this entry size, no, entry size what? 8 bytes, 8 byte given now. This is also page and frames also loaded. All pages are same size. So what is this page size given? Is nothing but 4 KB, correct or not? With this reference I can get the data. Total page size, this no page size is 4 KB. Now number of entries, how many will be there here? So 4 KB by, so number of entries in inner page table equal to 4 KB by what? 8. It is nothing but 512 entries. So 512 entries will be the 0 to 9, 511, 512 entries will be there. 512 nothing but this should be what? 9 bits, isn't it? 9 bits. Now see, 12 bits already segregated, 9 bits means remaining how many bits will be there here? It is nothing but 11 bits only now, isn't it? 11 bits only now. But you can get a doubt, sir, if this 8 bits are there, if you taken here also 8 bit. Now total page size, this total page size also again 4 KB only. Sir, 4 KB divided 8 bytes, you will get 512, nothing but this should be 9 bits only. How 11, sir? but they did not mention about entry bits here. They did not given. They said entry in a inner page table only mentioned. Therefore, in this case, if this entire page size is 4 KB, my entry value must be, page table entry value must be 2 bytes only. How, sir? So 11 bits will be there, 2 power 11, 2048 into 2 bytes, 4096 can come. So this must be 11 only, answer must be 11, like this we can solve it. So I hope this is clear, I hope this is clear. So next question, it is from computer networks, one more question frame date, So they given like something like this, routing information protocol, second one, B is given like OSPF, one is given like, so Dijkstra algorithm, and second one is given Bellman-Ford, isn't it? So they given mapping on the list, you have to map it. So now routing information protocol, nothing but what, which algorithm, this one? So DVR only, distance vector routing algorithm, this is what LSR, isn't it? So DVR we just which one? Bellman-Ford. OSPF you just what, Dijkstra algorithm. So one of the option will be there. So this way we can answer this question. So another question from computer networks, one more question is given now. IP version 4, okay, packet. So packet has X protocol number in the protocol field. So protocol field, we know, right, IP header format, if you see protocol field is there, that protocol field has what we have. So it can be ICMP packet, isn't it? IGMP packet, so TCP packet or UDP packet, correct or not? Yes or no? So it like, no, you understand now, OSPF like this, no, it will define here. Now what is the question asking, in this protocol? So protocol X cannot be, so this protocol number X cannot be, which one they given? ICMP, given IGMP, option C given RIP, option D given OSPF. Okay. ICMP protocol number, you know, right, 01, this is what, 02, TCP is 06, I think 06 or 7 will be there, I do not remember exactly. Okay, some protocol numbers are there. What is the question they are asking? Which of the following protocol number cannot be? Please do understand, ICMP uses IP services, IGMP uses IP services, please do understand now. So now OSPF also uses IP services, OSPF will not use either TCP or UDP, please understand now. RIP will not take the routing information protocol, will not take, please understand, will not take the help from IP, it will not take from IP, please, it is a UDP services. Therefore option C is the right answer for this question. Option C is the right answer for this question. I hope this is clear. Some more questions, so we'll discuss. So another faculty, JP sir, come. ఇప్పుడేనా?
Hello everyone, please confirm guys, am I audible? Yes, you can confirm. Now we are going to discuss few questions Yes, clear. Okay. So we are having few questions from the CS as well. So let's start with the very first question which has been asked in the CS. And this question is from the general aptitude. The same question has been asked in the IN as well. Okay, the basic question from the verbal bird. I will say the word analogy, bird, nest, to bee, and what should be the next. So the relation which we are having between bird and nest, the same to same we should have between bee and the next one. Where we are, here we are. Okay. So we can see the simple relation is bird's home is nest, so bee's home is hive. HIVE, hive. The simple question, the easier one. Okay. Then the next question I'm having again from the series question. Okay, the same question has been asked in the IN again. The same to same question has been asked in the IN. The series based question, find the missing term in the given series 5, 6, 15, 89, 170 or 291. Okay. If I'm talking about, so this will be the relation 5 plus 1. If I will go with 5 plus 1, so that looks 6, but 6 plus 1 is not 7 here, it is 15. So it should be 5 plus 1 square. Here the difference between 15 and 6 is the simple difference form we can apply here. So 15 and 6, the difference is 9. 9 means 3 square. So 1 square, 3 square, it should be 5 square. After that it should be 7 square, then 9 square. So when I am checking here, so this is 6. 6 plus 3 square means 15. 15 plus 5 square. 5 square is 25. That should be 40. So this number, the missing term should be 40, because when you are checking, you can cross check even key whether it is satisfying or not. So 40 plus 7 square. 7 square is 49. The 40 plus 49 is 89, right? 89 plus 9 square is 81. That is 170. So surely it is satisfying. So this is the simple answer. We can proceed. Okay, and then I'm having the question from the engineering maths, bachon. So the base good questions I'm having from the engineering maths as well for the CS. So let's start with the very first question of engineering maths. So here they are talking about, as the this type of question has been asked in the morning slot as well, but in that slot they ask about the eigenvalue. Here they are talking about the matrix itself. So it's talking about ki for the given matrix, A, the matrix is 1, 2, 2, minus 1. What is this? 1, 2, 2, minus 1. Okay. Find out, for the given matrix, find out the A power 8. I think they are asking about A power 8 only. And some options available. Let's check it out. What should be the answer here? So when I'm talking about here, very easily we can solve this question using the basic Kelly-Hamilton. A minus lambda I equals to 0. If you don't want to use the Kelly-Hamilton, then for the 2 cross 2 you can write down directly, because this is a 2 cross 2 matrix. Now the shortcut of Kelly-Hamilton is lambda square minus trace of the matrix multiply with the lambda plus determinant of the matrix and equals to 0. Directly we can write down. Okay. Or if you want to solve here, so then also the result will be same to same. 1 minus lambda 2, this is 2, this is minus 1 minus lambda, and the result equals to 0. When we are multiplying 1 minus lambda minus 1 minus lambda minus 4 equals to 0. Okay, or here if I am writing, this is lambda square minus trace is minus 1 minus 1. Trace is 1 minus 1, which is 0, into lambda determinant is minus 1 or minus 4. So this is minus 5 equals to 0. Though this will be gone, lambda square minus 5 equals to 0. Or I can say lambda square equals to 5. We can use here directly the Kelly-Hamilton. According to the Kelly-Hamilton, every square matrix satisfies its own characteristic equation. So lambda will satisfy by the A. So even here you can write down, what is this? Lambda square equals to 5 now. So we can write down, this will be A square equals to 5i. What I am looking for the a power 8. When you are looking for a power 8, then a square, take the power 4 both the sides, 5i power 4, this will be a power 8, and 5 power 4 or 25 square is 625, I power 4 will be I only. Okay, so this will be the result. So a power 8 will be 625 I bacho. If you are getting this one, you can confirm, isn't it? Then again one more question we are having from the algebra. This is the question of linear algebra, and one more question is there from the algebra, and the very basic question this time we are having. And this is the question ki given L, M, N, three matrices are given to you. Given L, M, and N are non-singular 3 cross 3 matrix. Are non-singular 3 cross 3 matrix or non-singular matrix of order 3, and L square equals to L inverse, M equals to L power 8, and N equals to L square. All these three things given to you. L square equals to L inverse, M equals to L power 8, or N equals to L square. Then what they are asking, they are looking for determinant of, then find the determinant of M minus N. Okay, let's see. First of all, I can use this condition which is given to me. L square equals to L inverse. When I am writing this will be L cube equals to I. Okay, the very first condition we can use here as an L cube equals to I. I am looking for the determinant, we can hold it. Even we can write down directly the determinant of L cube is 1. If it is required, we will use, otherwise maybe not required. Okay, then I can write down here what they are asking, M equals to L power 8. We can just break this 8 as in the power of 3. Why we are breaking this in the power of 3? Because we don't have any other thing. Now L is there only. We are having some result in terms of the L. So the M and N also we need to convert in terms of the L. So this will be L power 3, L power 3 or L square, means 6 plus 2, or if it is required you can write down directly. This will be 6 plus 2 na. So 3 square or square. Okay. So this will be L cube is I, or if you want to repeat, you can repeat. The thing is same to same, there is no confusion. Cube or square. So this is I, or this is L square. So I can say ki M is also L square. The value of M is L square, value of N is also L square. You are looking for the determinant of M minus N. So let's put the value first of all M minus N. Now what is M minus N? Then I will go for the determinant. So M minus N, M is L square and N is also L square. So L square minus L square is 0. So the result is ultimately 0. The determinant of 0 matrix, or I will say the null matrix is 0 itself. So result is 0. Very easily we can write down the result bachcho here as an 0. Okay. Now one basic question we are having from the integral calculus as well. So the next question of integral calculus, this they are talking about for the given definite integration. For the given integral, what is this? Integration 1 to x, right? T ln t dt. What is this? For the integration 1 to x t ln t dt equals to 1 by 4. Then we need to find out the value of x. We need to find out the value of x. So first of all, I need to go here with the integration. Integration is there. So we can say this is 1 to x t ln t dt. Okay. Integration by parts we need to use here. First function and the second function I can use here. The islet L is the logarithmic, so this will be first function, A is the algebraic second function. So this is my first function, this is my second function. So according to this one, first function is as it is. Okay, you can write down what is this first function is as it is, and different integration of second function, which is t square by 2 minus integration, and this time we are having the first function as an logarithm, ln x. So the differentiation of first function, which is 1 by t, and the integration of the second function, which is t square by 2, and then whole dt we need to go, and overall then we need to put the limit as well 1 to x. Okay, so I can write down this is ln x or t square by 2 minus the t will be gone, again 1 by 2 we can take outside, integration of t is t square by 2, so t square by 2 into 2 4, so I am writing it directly t square by 4. Okay, and the limit is there from 1 to x. When we are solving it, now we can put the limit, this is t, sorry, this is t. Okay, so this will be when we will put the limit here, so this is x square into ln x by 2. Okay, and minus this is x square by 4, and when I will put here the limit, so this is 1 na, so ln 1 is 0, and minus minus plus, this will be what, 1 by 4, and this result is already given to us bachon, this result is given to us e equals to 1 by 4, so I can take it e equals to 1 by 4, 1 by 4. Okay, 1 by 4, 1 by 4 gone, and I can make it more easy, I can take outside x square by 2, we can take outside, this will be ln x minus 1 by 2. Okay, and that is equals to 0. When we are solving it, ln x, this cannot be 0 because the function will be 0, x will be 0 in this case. So ln x equals to 1 by 2, x equals to e power 1 by 2 or square root of e. L will be e power 1 by 2 or square root of e. This should be the answer. If you guys are having the same, you can confirm. So I think these questions I get till now. Yes. So these questions I am having till now. If I will get more questions, you guys are having the more questions, you can share with us. Okay, we will try to come with the, if you are having the data, the exact data, you can share with us. We will try to come with the solution again. So now the remaining things will be there with the technical subjects. So please stay connected here only. The technical subjects will be continue here.
Yes, we'll see some more questions. So one question is from TOC. One question is from TOC. So which of the following? So which of the following? So which of the following accepted by is or accepted by DPDA? Option A is given regular, option B given CFL, option C any CFL, sorry, accepted by NPDA. They said here is any CFL, any decidable, any decidable language given. One more question asked from TOC. So which of the following? I think this is accepted DPDA only. So DPDA, like a PDA machine, PDA has two things, right? One is a DPDA, NPDA. Okay. So DPDA definitely will not accepted this one, correct or not? Because NPDA is more powerful than DPDA. He is saying any decidable language. Suppose example, some CFL language also, like suppose if you take any language which accepts NPDA is a decidable language only. So the decidable language cannot be accepted DPDA. This also incorrect, isn't it? Incorrect. CFL, any CFL. Suppose example, WW, like suppose WW such that W belongs to, so A comma B whole star is there like this. Okay. Some language CFL is nothing but it can be accepted DPDA, it can be accepted NPDA. The language, the CFL which is accepted by NPDA cannot be accepted DPDA, correct or not? Therefore, we cannot tell any CFL, we cannot tell. So definitely I can tell every regular is accepted by DPDA as well as NPDA. So this only one option is possible like this. So another question from TOC only. Another question from TOC. So grammar G1 is given. G1 is a grammar, context free grammar is given now. Context free grammar. So G2 is another grammar, it is also context free grammar is given now. So R is a regular expression is given. R is what? A regular expression given now. They ask which of the following. So which of the following is decidable? So which of the following decidable? Option A given. Language G1 is empty. Which of the following questions are decidable like this? Option B given. So language of G1 is equal to language of G2 like this. And also mention L of G is a language of grammar G like this. So option C is given like L of G1 which is not equal to, please understand, which is not equal to L of G2 is a question mark. Option D is given. So language of G1 is nothing but is equal to language of regular expression like this. Options are given now. So which of the following decidable? So now see, language generated by grammar is empty or non-empty. So when it comes to context free grammars, emptiness, finiteness, infiniteness, membership properties are decidable only. Please understand now. So therefore language of G is empty or not, I can, yes, we have a method to check whether decidable. We have a method to say that yes, it's a finite language, empty language, non-empty language. So this is decidable, isn't it now? So language of G1 generated, like grammar G1 generated, is equal to language of G2 generated. Equality is undecidable problem CFG. Not equal also undecidable. So now the language which is generated is regular or non-regular. So regularity also undecidable. So only one thing I can tell. So this what you can say, language of language of G1 grammar G generated is MTR or not finite, empty or non-empty is decidable. So like this we can able to solve this question. I hope this is clear. So another question from COA. Another question from COA. So which of the following included in the instruction set architecture? They are talking about which of the following is included in the instruction set architecture. So number of, option A give number of registers. Number of registers. Option B given clock frequency of a processor. Option C given so number of so option C given number of cache levels. Option D given size of cache memory. So initially we have learned like this computer organization architecture. There are two things we have: computer organization, computer architecture. Computer architecture it has like one addressing modes will be there, instruction set architecture, data format are the major components. When it comes to instruction set architecture, it should know that what addressing mode support, what registers are there. It is related to number of registers, part of the it is one of the component for instruction set architecture. So components are attributes of computer organization. If you see, memory components, processor, IO devices also comes here now. So number of, you understand, number of cache levels, size of the cache memory, no relation to what computer architecture. The separate memory components only. Without cache memory also I can design instruction set architecture, right? We have, so before earlier architectures do not have a cache memory. So like some later point of time cache memory introduction is there. So no relation this one. Clock frequency of the processor related to what? CPU clock rate, right? CPU is a CPU component, correct or not? So how many clocks are generated? It is also not part of the instruction set architecture, we can tell as per this data. So therefore I can tell like number of registers I can choose as an option. So I hope this is clear everyone. Yes, some more questions another faculty will discuss. Sir,
Hello students, I hope all of you till now you have seen whatever our faculties have discussed regarding the memory based questions that we have received from our students regarding CS afternoon session. Okay, so now we are going to discuss regarding the memory based questions regarding digital logic subject regarding computer science afternoon session. Okay, right. I hope all of you might have solved these questions correctly. Okay, if data wise if any correction is there, you people can cross check and confirm in the chart. Okay, so this is the question, actually MSQ. Yeah, this is a question regarding digital logic. Digital logic subject, question is of MSQ type. Question is of MSQ type. Okay, so here in this particular question they have given one Boolean function f of w x y z. Okay, so they have given the k map corresponding to f of w x y z. Now they are asking the function f of w x y z is equivalent to 2. Is equivalent to 2. So in this question they not asked the minimized function, rather they have asked that for the given k map, whatever the function you are getting, so you have to identify whichever functions are equivalent. Okay, so for this particular question they have given the k map like this, 4 variable k map. Okay, so here variables are wx and then yz. Right. So in this k map they have given 4 ones here and then they have given 4 ones here. This is the k map they have given and they have given 4 choices. Okay, and you have to identify among the 4 choices which one is correct, since the question is memory based. Okay, so that is the reason I am not giving all the choices, but for this question whichever choices are equivalent, I mean to say whichever expression they have given as equivalent, those expressions we are going to mention here as the choices. So here you can observe, you can do grouping of these 4 ones. So from here you are getting row wise x value 1, column wise z value is 1, xz, correct. Next, if you do grouping of 4 corner ones, if you do grouping of 4 corner ones, from there you are getting row wise x value 0, that means x bar, and then column wise z value 0, z bar. So in one of the choice they have given the equivalent minimized function. So for the time being I am writing here x bar z bar plus xz. So this option is correct. This option is correct. And one more option they have given like this. They have given like this. Now xz they have given, there is no doubt. Xz they have given. Okay. Now here they have given further terms like min terms they have given. That means xz you are getting because of this particular grouping. Okay. Now regarding remaining 4 ones, they not done the grouping, rather whatever the 4 min terms you are having, that expression they have given. So that means here w bar, x bar, y bar, z bar, that is your m0. Next, here this particular term w bar x bar row wise, then column wise yz bar, y into z bar, then for this particular row w into x bar, column wise y bar z bar, then here for this particular one row wise w into x bar, and then column wise yz bar. So this they have given in one of the choice. So this one also equivalent. So C and D they have given some other choices. So for this question the other 2 choices are not correct, only 2 choices are correct. Whichever 2 choices are correct, accordingly you have to choose. I hope all of you might have chosen whichever option like this you are having, you might have chosen, but for this question since they have asked that equivalent means it need not be minimized. Whichever function is equivalent, for this particular K-map, all those functions you have to choose. Okay, this is a very interesting question. At least the moment you got this option as correct, at least when you have cross-checked, XZ is matching. So XZ matching means with the help of this grouping of 4 ones you are getting, that means remaining 4 ones. When you have observed here, in every product term, you are having 4 literals. When you are having number of literals is 4 and the number of given variables also 4, that means just cross-verify whatever the 4 min terms here you are having, whether you are able to get or not. If you are able to get, yes, definitely it is the equivalent function. Okay, I hope whoever paid attention for this particular question, damn sure you people might have chosen whichever 2 options you are having, these 2 expressions accordingly. Okay, right. Now we are going to solve one more question regarding digital logic subject, that is regarding ripple counter. So this is the question regarding ripple counter. So they have given that the ripple counter is having 4-bit ripple counter, and in this question it is mentioned that, so since you are having 4 bits, definitely there will be 4 T flip-flops. Okay, and in this question they have given the time period at last flip-flop, the time period at last flip-flop. Okay, time period at last flip-flop. So here they have given that 64 microsecond. Okay, so now what they are asking, frequency of the clock frequency. Okay, the clock frequency, the input clock frequency we are supposed to calculate. So for this question, the input clock frequency we are supposed to calculate in the order of kilohertz. See, this is a very interesting question with respect to ripple counter. So at starting stage you are having LSB output, then like suppose when you are having 4 bits like Q3, Q2, Q1, Q0. So first stage you are getting Q1, Q0, second stage Q1, third stage Q2, and fourth stage Q3, like that. Okay, so now you no need to bother which one is LSB, which one is MSB. But in this particular ripple counter you are having 4 stages. So at first stage you are getting, since you are having 4 stages, okay, so for every stage or I can say at 10th stage, okay, generalized case, the output frequency you are getting f clock divided by 2 power n. Okay, since in this question 4 flip-flops are there, so at the 4th stage, last stage means what? 4th stage. So there you are getting the frequency as f clock divided by 2 power 4. I hope all of you are getting the clarity. See, first stage you are getting f clock by 2 power 1, second stage f clock by 2 square, third stage f clock by 2 power 3, and then last stage or 4th stage, that is f clock by 2 power 4. So this is the frequency. But here they have given time period. This time period, if you do the reciprocal, from there you are getting frequency 1 by 64 micro, you can write it as 10 power minus 6. I hope all of you are getting the clarity. Okay, now here you can do simplification. So 2 power 4 is nothing but 16. 2 power 4 is nothing but 16. So this 16 here 4 times, 16 here 4 times, and 10 power minus 6 you can bring to the numerator, it will become 10 power 6. So if you rearrange this equation, from here you are getting f clock equal to 10 power 6, I am writing it as 1000 into 1000, and another 1000 I can write it as kilo, right? Denominator you are having 4, so here 4 250 times, 4 here 250 times. Okay, so from here you are getting 250 kilohertz. 250 kilohertz. Answer for this question is 250. Okay, I hope all of you got all of you are able to cross check whatever the questions we have discussed in this particular session regarding computer science afternoon session. I hope all of you are able to verify whether your answer is correct or not, and definitely whatever the session here we have discussed, like common subject questions like mathematics, general aptitude, digital logic, okay, the common subject questions, okay, which are going to even whoever having electrical paper on tomorrow, and similarly EC paper on February 15th. Definitely you people are going to get maximum benefit with the help of the live solutions which we are discussing in our YouTube channel at our IMS Gate Academy YouTube channel. Okay, all of you stay tuned. Whatever the upcoming like live sessions are there, as per the respective branch, you people can attend accordingly, and definitely you people can get maximum benefit by cross verifying, okay, whether like whatever the solution part we are discussing here. Okay, so till now whatever the memory based questions we have received, accordingly we have discussed the solutions. Okay, right. Thank you everyone.